And then we have the term isometry. Okay, iso means equal, metry is measure. So the definition of isometry is a transformation that preserves length and angle measurements. In other words, it keeps it equal to what it was before. Isometry. Transformation that preserves length and angle measurements. Any questions? All right. Graph quadrilateral ABCD with the vertices as given. Find the image of each vertex after the translation x plus 3, y minus 1. Then graph the image using its prime notation. Okay, the prime notation is the new points. So what do you think I'm going to do to the points, each one of those points, to go from the pre-image to the image, given that translation? What do you think I'm going to do?
Add 3 to all the x's.
Right. You add 3 to all the x's and subtract 1 from all the y's. Okay, so that's the work here. So they draw A, B, C, D. Add 3 and subtract 1 from the y. So it's going to look like, so we do that to A. A is negative 1, 2. I add 3 to negative 1, it becomes 2. I subtract 1 from the y, it becomes 2 becomes 1. I do that for each point. That tells me what my new points in prime notation are. You can see this little mark means prime. Okay? So I have translated those points along that vector. Okay? Of 3, negative 1. You've got a graph there. You can move those points. 3 for the x would be 3 to the right, and negative 1 for the y would be down. Right is positive, left is negative, up is positive, negative 1 is down. Negative is down. Everybody have everything on this slide? No? Oh, there's what it looks like, okay? So the red is, this is the pre-image, and then after I move it to the right 3 and down 1, the red figure is what it would look like after you've translated. So you'll want to go ahead and do that on your graph. Okay, does everybody have it? No? Still working? All right, so now here's another one. Draw a triangle RST. So they've got a graph for you there. Plot those points. Then find the image of each vertex after a translation of going from x to y translates to x plus 1, y plus 2. Graph the image using prime notation. So you're going to do the same thing. Each point, you're going to add 1 to the x value, 2 to the y. You're going to plot the original points, and then the new one after you have translated it. Okay, so go ahead and do that on your own. Everybody have it? All right, so here's what it should look like. Your points would have been, after you translated them, those are the points values you should have gotten. And what that would look like on the graph is as follows. Any questions on translating? All right. So now we have the image of xy is translated to x plus 4, y minus 7, is the line segment P prime Q prime with endpoints. Here you go, Brandon. We started notes about 10 minutes ago. You can watch the video to cover what we missed. So is P prime Q prime with the endpoints P prime negative 3, 4 and Q prime 2, 1. Find the coordinates, the endpoints of the pre-image. Okay, so the cart before the horse. This is after the translation. This is what I did to the pre-image to get to this. So what do you think we need to do to, like, take P? What do I need to do to the values of P to get back to the original? What would I do? What would I do to negative 3 to get back to the original point?
Minus 4?
Yes, you would do the opposite operation. We would subtract 4, and for the y, we would add 7. We're going in reverse. So go ahead and figure out what those original points would be. Everybody got it? Okay, so here we add 4 to, we subtract 4 from negative 3, we get negative 7. We add 7 to 4, we get 11. Everybody got it? All right. And then they do the same thing to Q. Those are the values you should have gotten. Write a rule for the translation of triangle ABC to triangle A prime B prime C prime, then verify that the transformation is an isometry. All right, so to do that, okay, so what are we doing? We got to think in terms of x horizontal and y vertical. To go from C to C prime, what am I doing to the x value? What are we doing to go from C to C prime? What am I doing horizontally? Am I adding or subtracting?
Subtracting.
We're subtracting. How much am I subtracting? Eric?
5.
1, 2, 3, 4. We're subtracting 4. Okay? What about going from C to C prime vertically? What am I doing? Devin, when I go from C to C prime vertically, what am I doing? What?
C to C prime.
Yeah, C to C prime. Just vertically, what am I doing?
Going up 1.
Right, we're adding 1. So here's the solution. So that how you would state that is you would say x, y, and then draw an arrow, and then say x, we're subtracting 4, y, we're adding 1. That's the operation. Okay, so that's our rule. Okay, that's our rule. And to test if it's an isometry, okay, you would just compare the distances, right? When we go from the B to C, that's 3. B prime to C prime is 3. C prime to A is 2. C to A is 2. And then the diagonal is, it's a diagonal of down 2 over 3. So we've maintained distance, so it's an isometry. Okay, now we're going to get into vectors. This isn't really any different than what we've been doing. It's just another different way to think about how to notate the translation. So vectors, a vector is a quantity that has both direction and magnitude. Okay, so the direction of the arrow of the vector matters, and the length. The length of the vector gives its magnitude. The vector is represented in the coordinate plane by an arrow drawn from one point to another. The initial point is the starting point of the vector. The terminal point is the ending point of the vector. Do I have it? All right. So component form. Component form is just a different form to express the vector. In component form, it combines the horizontal and vertical components the horizontal component goes left to right. The vertical component goes up and down. Oh, make sure everybody get all that written down. Does everybody have all that? Okay, so then name the vector and write its component form. All right, so to name the vector, you would name it, you start with this initial point. The end with the arrow on it is the terminal point, the end, okay? So this would be vector BC, so it's BC with an arrow over it, or a ray over it, as you can see. From the initial point B to the terminal point C, okay, just like we were doing before, to go from this point to this point, I count how far horizontally I go? 9. So that's going to be the first value in my vector component. And then I'm going down 2, -2. Okay? So I have these brackets. They're not parentheses, they're angled, okay? That's just the vector notation. So that's 9, -2. This is the same thing we were just doing in the sense that if I could also write this as xy, and then I'd have x plus 9, y minus 2. It's the same thing, just a different way to express it. Does everybody understand or see what I'm talking about there? Does it make sense? So if they ask for vector form or component form, okay, when they ask for component form, I'm going to state it like this, okay? Name the vector and write its component form. All right. Somebody want to name the vector? What vector would this be? Carly, what vector would this be? Say again? Tx, right. She named the t first because that's the initial point. The final point is x. So you'd write tx with an arrow over it. Okay? And then what is my component form? Somebody want to take a shot at that? Aaron, what do you think? What's the component form of this? 0, 3, right. It doesn't move left or right any, so it's 0. It goes up 3, so it's 0, 3. Everybody have it? Okay. Let's see what the tx, yeah, okay. All right. Go ahead and do this one on your own. Okay. Okay, we'll do it orally then. Let's see. Name this vector, Gunner. No, not the component. The vector. Name the vector with letters. ST, right. It's vector S. Oh. It's ST with the line over it. And the component form of this vector, Abby, would be what? Okay, your horizontal value goes first. What is it changing horizontally? Okay, so that's the one that goes first. What would that be? Yes, that's -8. And the vertical component? 0. Right. Make sense? All right. So there's the solution. And let's see. Okay, so this, you have this one in your notes? Yeah, okay. So the vertices of triangle LMN are 2, 2, 5, 3, and 9, 1. And translate LMN using the vector -2, 6. Okay, so you start with your original points. Go ahead and translate those on your own, and then I'll put the solution up. Translate those on your own using the same form. So you're going to have, I think it's already written for you in notes. You've got L, 2, 2, and then they have an arrow, and it's going to be L prime, and then you're going to put the new values. All right, everybody had a chance to do it? Okay. Okay, let's look at the result. So if we do this translation, so they went ahead and went back to the original form. Just another way of expressing this, and then you would subtract 2 from the the x value, and you would add 6 to the y value, 0.8. Okay, so you do that on all the 3 points, and that's what you end up with. Any questions there? Everybody has it. Okay. All right, so that's it. Okay, so you've got